In today's lesson, we're going to be practicing lots more trig functions in all four quadrants again. And I just wanted to start with this picture because it shows this angle theta with its initial and its terminal side. And it has it sort of pictured on a circle. So we think of that circle as having a radius of r, and it hits this point. Like we learned yesterday, we call that point x, y, whatever it is, but the horizontal and vertical coordinates just happen to make our right triangle. So remember that when we evaluate sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent opposite over adjacent, we get these kind of cool definitions that helps us figure out what the trig ratios of those angles are. Now, it's kind of a special type of case when we have angles like 90 degrees, angles that wind up like not in a quadrant, and then for some reason they call those types of angles quadrantal angles, but they're not even in a quadrant, so whatever. So let's look at 90 degrees. The terminal side is that vertical ray right up here. And so we're just going to pick a point that's on that terminal side. Let's pick a point. I tend to always pick, well, we know it's going to be 0, comma, whatever you want, but I always pick 0, comma 1 just cause. And that means my x value is 0, my y value is 1. And then if you think of the radius of that circle, well, can you picture that circle? The radius is 1. The radius is 1. And sometimes they call that the 1 unit circle. And so that's the title of this lesson, is the unit circle. But that's all there is to it. If you can get an x, a y, and an r on the terminal side of your angle, you can throw out these answers like nothing. Sine is y over r. Sine of 90 degrees is 1. Cosine of 90 degrees would be x over r, 0. Tangent of 90 degrees would be y over x. 1 divided by 0 is undefined. So even if you tried to type that into your calculator, say you were in degree mode, and you typed in tangent of 90 degrees, I think it gives you an error. It's undefined. One more, so here's another example of a quadrantal angle, because if you make an angle of pi, remember pi is the same thing as 180 degrees. No way you're making a right triangle out of that. And so what we're going to do every time is pick a point on the terminal side of the angle. So this one's going to be negative something 0. You can pick any something you want. I'm going to pick negative 1. I always do. And then if you picture that circle, again, it's just a 1 unit circle, right? The radius, like from the center to that point, the radius is just 1. So we've got an x value, a y value, and a radius. So no problem. Now we can do sine of 180 degrees. Sine of pi in radians would be y over r. Cosine, x over r. Tangent, y over x. 0 divided by negative 1 is 0, so this one is defined. Those are quadrantal angles. So you have to, I don't think they're all that hard, but we're not making a triangle at all. We're just relying on our x, our y, and our r. So we are going to find these answers without a calculator. Who needs it? Who needs the calculator? So let's talk about 120 degrees. Step 1, we're going to draw 120 degrees. Something like this, right? Okay. Can't make a right triangle out of that, so we're going to use the reference angle. The reference angle is going to be this guy right in here. And that angle, if we're trying to get to 180, that would be a 60 degree angle. Are you seeing it? A 60 degree angle. We love 60 degree angles because we know that triangle. That triangle, let's just draw it. And I'm drawing it in the second quadrant because my 120 degrees was in the second quadrant. So we've got a 30, 60, 90 going on. That's a 1, 2, square root of 3. The thing you want to be careful of is, remember, if I'm going backwards 1, I'm going to have to call that a negative 1. And that's a little tricky to remember. This is a positive y value. Our radius is always positive. So what we're going to do, in order to find cosine of 120 degrees, we're going to use this reference angle. We're going to reference this triangle. So cosine would be the adjacent over the hypotenuse. Negative 1/2 is the answer for that one. Negative 45 degrees. Let's draw that. Always starting on the positive x, a negative angle rotating this way. And the reference angle is just that one that brings us back to the x-axis. Our reference angle is a 45-degree angle, which I love because I know everything there is to know about 45, 45, 90 triangles, yes? Notice that one of the sides of my triangle is always on the x-axis. That terminal side is always my hypotenuse, and I've got a 1, 1, square root of 2. You want to think, are any of those negative? Well, this would be a positive x value, a negative y value, and the radius is always positive. Once you have your reference triangle drawn, we can do our SOHCAHTOA. So sine of that reference angle is opposite over hypotenuse, negative 1 over the square root of 2. Not going to let you leave it like that, so we'll have to rationalize our denominator. Final answer, negative square root of 2 over 2. Now, even if you did type that in the calculator to give you some ugly decimal, we're looking for that exact answer. One more time, 240 degrees. 240. Let's see if we can draw that. So we'd get ourselves to 180. And then go a little further. That's almost to 270, isn't it? Only 30 degrees away from 270. So now where's the reference angle? It's the one right in here, the one that brings us back to the x-axis. And how far past the 180 did we go? I think that's 60 degrees, yeah? Oh, I love that kind. If it's a 60-degree angle, I can make myself a triangle where the terminal side is the hypotenuse, the x-axis is one of the sides, and we'll just connect those to make a nice right angle. A 60-degree angle, 1, 2, square root of 3. Are any of those negative? This is a negative x value because we're in the third quadrant. In the third quadrant, x values are negative, y values are negative, radii are always positive. Let's do a tangent. So the tangent of that reference angle, opposite over adjacent. We'd get positive square root of 3. Which, if I did let you use a calculator, would just show up as like 1.7-ish. Positive, though. You're going to have to be able to do this over and over again. I think just to keep this shorter, let's go on to just some examples that have radians, okay? Because I think we probably need practice on drawing these angles with radians. Okay, if I'm going to draw a 3 pi over 4, I'm going to want to split my top half into 4 equal pieces. There's 1, 2, 3, 4. 1, 2, 3 pi over 4s is the one I'm looking for. And that means my reference angle is right in here. How big is that reference angle? Well, 180 divided by 4 is 45 degrees. Each of these was a 45-degree angle. So my referencing, I'm going to write it in degrees because it's not going to matter in the end. We have a 45-degree reference angle. Love that. I've got a hypotenuse on the terminal side. I'm going to use that x-axis as another side. Make a nice right triangle out of that. 45, 45, 90. 1,
1 square root of 2. Which ones are negative? In the second quadrant, just the x value is negative, y is positive. There we go. So, you know, it's not all that hard. If you can get that triangle drawn, then you just have to do your SOHCAHTOA. So we've got a reference angle right here. This is the 3 pi over 4, but we're going to use this triangle. So opposite over hypotenuse, positive 1 over the square root of 2, which rationalizes into square root of 2 over 2. Let's keep going. Dividing into thirds, huh? Okay, so we have to kind of ignore that. So we've got 1, 2, 3. I think I'm going to need the bottom half, so I'll split that again. I've got 1, 2, 3. If you can picture that. Let's draw 5 pi over 3. So let's count them. 1, 2, 3 gets us to 180. 4, 5, and we wind up down in the 4th quadrant, where the reference angle is a pi over 3. Pi divided by 3 is the same thing as a 60-degree angle. Every single time, guys. Every single time you're winding up with a 30, 60, 90. 1, 2, square root of 3. Are any of them negative? Yes. Tangent. Tangent of this reference angle, negative square root of 3 over 1. All right, one more. Pi over 6. You know, it's going to be negative, so I think I'll split the bottom half into 6. So each quadrant needs 3. So that's 6. 1, 2, 3, 4, 5, 6. Initial side on the positive x-axis, rotating clockwise this time, just 1 pi over 6. What kind of reference angle is that in there? Connecting back to the x-axis. It's just a pi over 6. 180 divided by 6 is 30 degrees. There it is again. A 30, 60, 90. 1, 2, square root of 3. Any of those negative. X is positive. Y is down, so that's negative. Radius always positive. Now we're thinking secant, which is an upside down cosine. So I'm going to do hypotenuse over adjacent. That'd be 2 over the square root of 3. Can't let you leave it like that, so we're going to rationalize. 2 square root of 3 over 3. You won't have a calculator for this, and your answers will be exact just like that. That's the idea of this lesson.